SCR. So ano nga ba SCR? So the silicon controlled rectifier is a 4-layer, 3-terminal solid-state device to switch very large currents on and off. They are designed to handle higher values of current and voltage compared to other thyristors. Some SCRs are capable of controlling currents up to 1.5 kiloamperes and voltages in excess of 2 kilovolts. Because of this, they are used in power switching, phase control, chopper, battery chargers, and inverter circuits. Industrially, they are applied to produce variable DC voltages for motors and AC line voltages. SCRs can also be found in welding power supplies where they are used to maintain a constant current or voltage. Large SCR assemblies, which with many individual devices connected in series, are used in high voltage DC converter stations. So, yung SCR, isa siya example ng thyristors. Primarily, ginagamit siya bilang switch. Ano yung advantage niya sa ibang component? Ang advantage kasi ng SCR is may kakayahan siyang mag-switch ng high current and voltages. Kaya madalas ginagamit si SCR for industrial purposes. Okay? So some ng application niyan, ang nakalagay nga dito, power switching, phase control, chopper, battery chargers, and inverter circuits. So yung SCR, unlike kay diode na may 2-layer na semiconductor material, kay transistor na 3-layer, si SCR or the thyristor has a 4-layer semiconductor material. So ito, PN yung kanyang semiconductor arrangement. Di ba? Kay diode, PN lang. Kay transistor, NPN or PNP. Then kay SCR, we have PNPN. So meron kang 4 na layer ng semiconductor device. Kung mapapansin nyo, okay, meron ang schematic symbol niya is parang sa diode lang. Okay, meron siyang anode, then meron siyang anode, tsaka meron siyang cathode. So ang nadagdag is meron siyang tinatawag nating gate. So ano ba yung kahalagahan ng gate na yan? So mamaya madidiscuss yan. Then we have here, kung bibili kayo ng SCR sa mga electronic shop, so ganito yung itsura ng isang SCR. Then, sa datasheet ng isang SCR, meron kayo doon makikita na mga parameters, okay? So ano ba yung mga parameters na yon? So a typical SCR datasheet will contain figures for the following parameters. First, we have the forward breakover voltage. Ano ba yung forward breakover voltage? It is the voltage at which the SCR enters the forward conduction region. So dito, pag sinabing forward breakover voltage, ang ginagawa, itong voltage ito yung amount ng voltage kung saan yung SCR is mag-forward siya or mag-go-on. Okay? Ibig sabihin, ito yung voltahe para mag-on or yung voltage para makapag-on natin yung isang SCR. The forward breakover voltage. Then we have here the holding current. It is the value of anode current below which the SCR switches from the forward conduction region to the forward blocking region. Pag sinabing holding current naman, ito naman yung value ng current na kailangan mong i-maintain para manatiling naka-on si SCR. Okay? Then we have the gate trigger current. It is the value of gate current necessarily to switch the SCR from the forward blocking region to the forward conduction under specific conditions. Yung gate trigger current naman, ito yung tinatawag na trigger current. Ibig sabihin, ito dapat yung current na papasok dun sa ating gate terminal para ma-on si SCR. Then we have the gate trigger voltage. Ito naman yung voltage na kailangan pumasok sa gate para para ma-trigger on si SCR natin. Then we have the average forward current. It is the maximum continuous anode DC current that device can withstand in the conduction state under specific condition. Itong average forward current na to, ito na yung maximum na kuryente kayang i-withstand o kayang tagalan ng ating SCR habang nanatili siyang naka-on state. Then we have the forward conduction region. It is the region that corresponds to the on condition of the SCR, where there is forward current from anode to cathode through the very low resistance of SCR. Yung forward conduction region naman, ito yung operating region kung saan ito yung region kung saan naka-on si SCR. Kasi, for example, katulad doon sa, di ba nga, pag transistor, meron siyang on region, off region. Okay, sa diode, meron siyang forward bias, reverse bias. Dito sa SCR, yung tinatawag na forward conduction region, ito yung region kung saan naka-on si SCR. Or ito yung tinatawag niyang naka-on state. Then we have the forward blocking and reverse blocking region. So ito naman yung state kung saan naka-off yung SCR natin. Okay? Then we have the reverse breakdown voltage. This parameter specifies the value of reverse voltage from cathode to anode, on which the device breaks the abalanced region and begins to conduct heavily. Okay, pag sinabing reverse breakdown voltage, ito naman yung voltahe, okay? Ito yung voltahe kung saan yung current is nag-flow from cathode or from the negative to the positive. Pag nangyari yon, di ba? Di ba pag nangyari yon is para siyang ma-reverse bias. Pag na-reverse bias siya, okay, katulad do sa Zener diode, di ba pag na-reverse bias siya, pag masyado ng, or sa diode, masyado ng malaki masyado, reverse voltage, nagkakaroon siya ng tinatawag na avalanche. Sinabi kasing avalanche is mag-heavily conduct, or ibig sabihin, parang mag-short na mismo yung mismong electronic component mo. So, paano nga ba nag-ooperate yung SCR? So, yung SCR daw can be... Yes.
Excuse me po, pa-accept daw po.
Kala ko ano na eh.
Thank you po.
Yan, okay. So, yung SCR daw can be viewed as ito. Para siyang dalawang BJT. Okay? Pair siya ng dalawang BJT. Isang PNP, tsaka isang NPN. Okay? Paano pa yung operation niya? When there is no applied voltage at the gate, okay, pag both transistors will be on the off state. So pag wala kang voltaheng pinapadaan dito sa gate, parehong naka-off yan. Okay? Okay? If the pulse voltage is applied to the gate sufficient enough to turn on the NPN transistor, the collector current connected to the base of the PNP transistor will turn the PNP transistor on. As it turns on, the value of its collector current will increase, resulting to the corresponding increase in the base current of the NPN transistor. The regenerative increase in collector current in both transistors will make the SCR resistance too small. Thus, it is represented by short circuit. So, mangyayari, okay, pag nag-input ka ng voltahe rito, okay, so isipin nyo, sa una, pareho silang naka-off. Pag nag-input ka ng voltahe dito, okay, mangyayari is mau-on mo tong NPN transistor na to. Mau-on yan. Ito, hindi mo ito muna mau-on. Pag na-on mo to, okay, pag na-on mo to, ibig sabihin, magkakaroon ngayon ng kuryente. Yan. So, magkakaroon ka ng collector current. Pag nagkaroon ka ng collector current, yung collector current na to is magiging dahilan para magkaroon ka ng collector voltage dito. Yung collector voltage naman dito, siya naman ngayon yung magiging dahilan para may pumasok na voltage sa base nito ng PNP. So pag nangyari yon, pag may pumasok sa base ng PNP, mau-on to, yan, mau-on yan, kakaroon ng current na ngayon dito sa PNP. Pag nagkaroon ng current, mangyayari niyan is magkakaroon ulit ng voltage dito. Papasok dun sa NPN. So, ang nangyayari, parang umiikot siya, but every cycle is nadadagdagan yung voltahe mo, ay nadadagdagan yung current mo. Kasi pag masok ulit siya dito, may IC ulit dito, papasok ulit dito, yan. So, yung ang tinatawag na yung regenerative increase in collector current, ibig sabihin, mag-i-increase yung collector current mo dito, pag pumasok dito, mag-i-increase naman dito, na siya papasok dito. Since na-increase na yung current dito, yung lalabas na dito is na-increase na naman yung current niya dito. So, ang mangyayari niyan is pag yung regenerative action nung pag-increase ng collector currents ng PNP at NPN, yung magiging dahilan para ka na lang ding may short circuit dito. Yan. Sabihin, magko-conduct na yan. Ito, represented by short circuit. So, ganun yung operation ng SCR. Okay, isipin nyo na lang. For example, yung gate ng SCR, maglalagay ka doon ng certain amount ng voltage para mag-switch yung SCR. For example, ganito siya. Kung ito yung anode, ito yung cathode ng SCR, ito yung gate. Okay. Yan, ito yung, for example, may switch. Maglalagay ka ng voltage papunta kay SCR para mag-switch to. Mag-on. So, yun yung trabaho ng gate sa SCR. Yung dadaan sa gate, yun yung dahilan para pag nag-switch to, magkakaroon ka ngayon ng flow ng current from anode to cathode. So, ano yung kinakailangang input voltage sa may gate? Ito yon, Bin. Bin is equal to VGT plus IGT plus RG. Where yung VGT dito is yung gate threshold voltage. Nasa specification niya. Then yung IGT, okay, gate threshold current plus yung RG. Okay, so let's see. So, pag na-on yung SCR, okay, kahit tanggalin mo yung voltage sa gate, mananatili pa rin siyang naka-on. Tingnan nyo dito. Ito. Di ba nga, na-switch on ko na siya. Ibig sabihin, shorted na yung from anode to cathode. Pag tinanggal ko yung gate, shorted pa rin siya. Ibig sabihin, nagko-conduct pa rin siya. So kung gano'n yung mangyayari, paano mo i-reset o ito turn off si SCR? So ito iba't ibang ways. First, reducing the anode to cathode current to a value less than its holding current by reducing the value of VCC. So, kailangan mo daw bawasan yung value ng source voltage VCC mo, okay, para yung holding current mo is lumiit or yung current from anode to cathode. Pag lumiit yun, okay, so mata-turn up na si SCR. Anong value ng VCC kailangan? So, ang value ng VCC na kailangan para ma-turn up would be 0.7 volts plus IH is times R head. Okay? Then we have here yung current interruption, then force commutation. Pag sinabing current interruption, so you are forcibly interrupting yung current from anode to cathode. Ibig sabihin, putulin mo mismo yung linya from anode to cathode. Then yung force, so yung sa force commutation, so tatanggalin mo lahat ng supply doon. Okay? Sa SCR mo. Yan. Ito, let's see kung paano siya i-apply. For the following SCR circuit, determine the input voltage that turns on the SCR and B, the supply voltage that turns it off. So may SCR circuit tayo dito. Nasa SCR dito. So ito SCR ha, kung baka din yung makita. Ito yung SCR. Ayan o. Ito yung symbol niyang SCR eh. So ano daw yung kailangan na voltage para ma-turn on? Ano daw yung kailangan dito sa gate or input para ma-turn on? Okay? O, dito input. So ano formula for input? So Bin is equal to VGT plus IGT multiplied by RG. Okay? So given na yung gate threshold voltage kasi nasa specs naman yan, then we have IGT 7 milliamperes. Okay, so therefore, ang Bin would be VGT plus IGT times RG. Yung RG is kung meron bang any resistance na nasa gate, which is 1 kilo ohms here. So we have 0.75 volts plus 7 milliamperes multiplied by 1 kilo ohms. That will be 7.75 volts. So yung input na to, ito yung kailangan para ma-turn on mo si SCR. Next, ano naman tayo voltahe para ma-turn off mo siya? So, para ma-turn off, kailangan mong i-reduce to, yung BCC. Sa anong value mo i-reduce dapat si BCC? So that will be BCC is equal to 0.7 volts plus IHRL, where IH is the holding current and RL is the load current. Okay, ito siya. So RL is 100 ohms, IH is given 6 milliamperes. So therefore, bawasan mo daw para maging 1.3 volts yung ating BCC para ma-turn off si SCR. Next, for the following SCR circuit, determine the peak output voltage, the frequency of the sawtooth wave if its period is approximately 20% of its time constant. Okay. So, ito na. Meron tayong circuit dito. So, we have here capacitor C1, 0.2 microfarads. We have R2 and R3. Okay. So, paano ba siya? So, first, we have to determine the peak output voltage. Okay. Kailan ba masusukat yung peak output voltage? So, kailan mo masusukat yung peak output voltage dito? Yan. Kailan? So, masusukat mo yung output voltage sa point na to, okay, habang or bago mag-fire. So, before firing point. So, before firing point, ito din yung mismong instant ng firing point. Okay. Doon mo masusukat. Bakit doon mo masusukat? Kasi, so pag nag-fire yan, ibig sabihin na fulfill mo yung gate voltage dito, ibig sabihin, since naka-open pa to, so bago siya mag-close, is yung punto na bago siya mag-close circuit, yung punto na naka-open pa siya, is yun yung time na masusukat mo yung maximum output voltage, which is yun yung time of firing point. Kailan ba siya nagpa-fire? Magpa-firing point siya o mag-on si SCR kapag sufficient yung voltage sa gate mo. So, tingnan natin. So, let's first find yung input voltage para mag-on si SCR, which is Vin, VGT plus IGT, RG. Ano ba yung RG? Ano yung ating resistance sa gate? Yung resistance sa gate is mapapansin nyo, wala dito. Kundi andito. Ibig sabihin, kukunin mo, kung since ganito yung configuration, kukunin mo yung equivalent resistance. Resistance equivalent yan. Paano mo kukunin? Pag ganyan, ang equivalent resistance yan is, since sa gitna ka kukuha ng equivalent resistance, is it's para lang yang may dalawa kang parallel na resistors na 900 tsaka 100 ohms. So 900 parallel with 100, that will be 90 ohms. Okay? Yun yung RG natin. Therefore, ang Bin natin is 1 volt. Okay? Ano pa yung 1 volt na yon? Yung 1 volt is VGT. Then IGT is 200 microamperes. So therefore, 1 volt plus 200 microamperes multiplied by 90 ohms. Ang Bin natin is 1.018 volts. Okay. So ito yung input voltage para mag-fire si SCR. Okay? So di ba sabi ko kanina, masusukat mo yung voltahe sa instant na mag-fire yung SCR. Ano ba yung voltahe sa instant na mag-fire si SCR? So 1.018 volts, di ba? So ano ngayon daw yung output voltage natin? Okay. So dito, so ilista ko lang ah. 900. Okay. Ito yung V-out. Ano daw yung V-out na to? Alam naman natin na yung voltahe rito is 1.018 volts. Tama ba? So, paano mo ngayon nahanapin si V-out? O yung voltahe dito sa may gitna is 1.018 volts. So, using voltage divider, okay? So, using voltage divider, So, paano mo hanapin yan? So, voltage divider, ibig sabihin, since ito, yung V, let's say, R1 ay ano ba yan? R2. R2, R3. Okay. So, kung mapapansin nyo, pag sinukat nyo, yung 1.018, since ito yung ground natin, 1.018 is a voltage drop kay R3. So, therefore, so 1.018 volts is equal to V out multiplied by yung kuhanan mo ng voltage which is R3, then yung summation ng voltage natin sa voltage divider. Kaya ito siya. So therefore, ang magiging kanyan, V out multiplied by 100 ohms over 900 ohms plus 100 ohms. Then that will be 1.018 volts is equal to V out multiplied by 100 ohms over 1,000 ohms. Then solving for V out, our voltage output will be 10.18 volts. Yan. So that's our output voltage. Then yung pangalawang question, when the ano daw yung hinahanap sa pangalawa? The frequency of the sawtooth wave if its period is approximately 20% of the time constant. So let's first take muna natin kung naka-off si SCR. Pag naka-off si SCR, ibig sabihin, wala tong side na to. Okay? Pag wala yung side na yan, ang magiging itsura ng circuit mo, pag i-reconstruct mo yan, yan. Okay. So, tingnan natin. Pag naka-off si SCR, ito yung tsura niya. Wala yung SCR side. So, mapapansin nyo, kung sa point na to, kung kukunin mo yung equivalent resistance ng mga resistor na to, so para ka lang may parallel ka ng 1 kilo ohms, tsaka nung naka-series connection na to na 900 plus 100. Yan. So therefore, so para ka may parallel na dalawang 1 kilo ohms. So ang equivalent resistance na ngayon is 500 ohms. So pag i-reconstruct mo yan, okay, may RC ka na, RC network. So kung ito 500 ohms, ito 0.2 microfarad, okay, kasi equivalent resistance ito eh. Then, yung time constant ng capacitor tau, okay, so yung time constant is equal to the resistance and yung capacitance ng isang RC network. So therefore, so tau or the time constant is 500 ohms times 0.2 microfarad. That will be 100 microseconds. Okay? Then, since the period of the sawtooth is 20% of the time constant, then kukunin mo ngayon yung period ng sawtooth, so 20% ng time constant, that will be 20% ng 100 micro, that will be 20 microseconds. Pero ang hinahanap is frequency. Ang andito is period. So period is ano? Period is reciprocal ng frequency. T is 1 over F. Or if you will need to find yung frequency, that will be reciprocal ng period. So kung ang period natin is 20 seconds, that will be 1 over 20 microseconds. So ang frequency ngayon ng ating sawtooth wave is 50 kilohertz. Then, so yan, grinap ko lang, isang sawtooth. Ganito yung itsura ng isang sawtooth wave. Yan. So may question ba about sa SCR? Isa may input voltage, kailan nag-on? May question ba so far? Problem? Sample? Uy, ano, may question ba so far? Okay lang? Ano, okay lang? May question ba? Wala.
Wala po, sir.
Okay, so let's now go on. Ano ba yung kadalasang application ng SCR? First, yung tinatawag nating phase control. So sa phase control, SCR together with the coupled RC circuit can alter the phase of the output signal. So with the use of variable resistor, the average current through the load can be controlled. This is useful for changing the speed of a motor, the brightness of a lamp, or the temperature of an induction furnace. So sa phase control, so meron tayong tinatawag na conduction angle. Ito yung number of degrees during which the SCR is turned on. And yung firing delay angle, it's the number of degrees of an AC cycle that elapses before the SCR is turned on. Pag sinabing conduction, yun yung angle na kung saan nagko-conduct si SCR, then yung firing delay is before siya mag-conduct. Okay? So the firing delay angle is the amount of delayed phase shift of the capacitor. And the conduction angle can be determined by subtracting the angle from 180 degrees. The impedance and phase shift of the RC circuit can be determined by the formulas. Ito, ZT or yung impedance ng tawag dito, ng resistor tsaka ng capacitor, yung RC circuit natin. So we have square root ng R squared plus XC squared, where XC squared is ano? XC squared is yung tinatawag na capacitive reactance. Then, to find the angle of the impedance is negative arctangent of XC over R. Okay? Then, the current and voltage in the capacitor is given by IC is equal to B in angle 0 all over ZT angle theta Z. Then, yung voltages naman is IC multiplied by XC angle negative 90 degrees. Bakit negative 90 degrees? Kasi, di ba, yung capacitor, okay, sa isang RC circuit, yung pure capacitance is nilalag niya yung current by 90 degrees. Kaya minus 90 siya. Then, we have here, ito yung typical na phase control circuit. So, meron kang AC source dito. So, meron kang variable resistance dito. May capacitor ka. Okay? Then, may load ka. Then, yung SCR mo. Ito, yung output waveform. Kung ito yung line voltage waveform mo, or kung ito yung AC voltage input mo, ang mangyayari niyan, pag sinukat mo sa isang oscilloscope yung waveform sa SCR or sa voltage sa SCR, ito yung makikita mo. Ito yung magiging itsura ng waveform. Then, kapag kinuha mo naman yung voltage sa load, okay, ito na ngayon yung magiging output waveform mo. Kung mapapansin nyo, kung mapapansin nyo sa waveform nung sa load, okay, kapag ang SCR, okay, is hindi pa nagta-turn on, okay, ang mangyayari is wala kang makukuha sa load. Ito, zero voltages. Zero voltage pa lang. Then, yun yung tinatawag na firing delay angle. Kasi hindi pa nagpa-fire. Okay, tingnan natin. So, once na dumaan dito, nag-fire. Okay? Once na nag-fire dito si SCR, okay, yung firing point, mangyayari ngayon, magko-conduct ngayon sa load. Kaya kung papansin nyo, ito siya, may conduction. May masusukat ng voltages. Bakit zero yung voltage pag nag-fire yung SCR? Zero kasi siya, pag nag-fire si SCR, ibig sabihin, di ba, magiging switch lang siya. Shorted siya. So pag sinukat may voltage sa isang short circuit, zero nga siya. So yun yung conduction angle. Ibig sabihin, pag nag-fire si SCR, ibig sabihin, nagko-conduct na siya ng current from anode to cathode, so may masukat ng voltage ngayon dito sa ating load. Then, uulit lang ulit yan. Okay, then sa negative cycle, mau-off ulit yung sa load natin kasi hindi pa nagpa-fire si SCR. Hintayin nyo ulit mag-fire. Magpa-fire siya sa point na to. Pag nag-fire ulit, sabihin, mag-short si SCR, sa load mo, may masusukat ka ulit na voltage. Okay. From this input, then yung makuha mo dito sa output load, anong napansin nyo? Pag kinuha mo yung average voltage dito, tsaka yung average voltage dito, mapapansin nyo, nabawasan siya. Okay? Then, makokontrol mo yan, depende dun sa firing delay tsaka sa conduction angle. Okay, so paano mo makokontrol? I-adjust mo ngayon si variable resistance. Yung variable resistor dito, pag in-adjust mo, pwedeng yung firing delay dito sa point na to, so pag dito yung sa point na yan, so ganyan yung itsura niyan. So pag dito naman, pag dito yung firing delay, so ang itsura niyan, ganyan itsura niyan, liliit kasi maliliit yung pag-fire niya. So, ma-adjust yung firing delay angle at conduction angle through that variable resistor. Okay? So, yun yung kaya tinatawag na phase control. Nako-control mo yung phase ng yan. So, let's have some examples here. So, for the SCR phase control circuit above, determine the firing delay angle, the conduction angle. If Vin is 100 volts, capacitor is 0.1 microfarad, and R1 is 40 k ohms. Okay, so let's see. So first, hanapin natin yung firing angle. Okay, to determine the firing delay angle, okay, we must first determine the phase shift of the capacitor. So determine the phase shift ng capacitor by this formula. BC is equal to IC times XC minus negative 90 degrees. Okay, kung ano yung magiging resulting angle nito, yun yung phase shift. So to find the current, IC is equal to B in angle 0 all over ZT theta Z. So, ito yung mga formulas. So, let's first find yung ZT or yung impedance ng RC network natin. So, given naman dyan is may C tayo, which is, ang capacitor natin is 0.1 microfarad. Okay? So, 0.1 microfarad. Ito yung value ng capacitor. Then, ang nasa formula, sa impedance, kailangan natin hanapin si XC or yung capacitive reactance. So yung capacitive reactance is 1 over 2 pi FC. So ito, napag-aralan nyo ito siguro sa circuits 2, okay, sa AC. So we have here 1 over 2 pi. Pag hindi naman binigay yung frequency, automatic yan, 60 Hz. Kasi ito yung line frequency voltage ng mga AC natin. Then we have 0.1 microfarad for the capacitance. So therefore, ang XC mo is 26.526 kilo ohms. Then finding the impedance, square root ng, so given naman yung R which is 40 kilo ohms. Yan. So our resulting impedance natin will be 47.996 kilo ohms. Then hanapin natin yung angle yung impedance natin, that will be negative arc tangent, 26.526 kilo ohms over 40, XC over R2. Okay? Then we have theta Z is negative 33.550 degrees. Okay. Yung IC natin, using the formula, IC is equal to V in angle 0 all over ZT angle theta Z. That will be 1, di ba? So, naturo naman sa inyo sa guro sa advanced math, di ba? Nung last sem lang, paano mag-divide ng mga polar form, okay? In polar form. So, 100 volts divided by 47.996 kilo ohms, that will be 2.084 milliamperes. Then, di ba, since division to, ipag-minus mo lang yung angle. So, 0 minus 33.550. That will be positive 33.550. Then, to find BC, okay, but kailangan natin si BC. Si BC kasi is yung voltage sa capacitor. So, pag hinanap mo yung voltage sa capacitor, malalaman mo din doon kung ano yung angle ng BC mo, yun na yung magiging conduction angle sa may capacitor. So, therefore, 2.084 milliamperes angle 33.550 multiplied by 26.526 kilo ohms angle negative 90 degrees. So nakuha to. Ito yung XC or capacitive reactance. Okay? So nasa formula naman na binigay ko yun kanina. Ayan, no. Ito. So therefore, sa multiplication naman, di ba, ng polar form, so multiply mo lang yung parehong magnitude, yan, 2.084 milliamperes times 26.526 kilo ohms. That will be 55.280. Then, 33.550 plus negative 90, that will be negative 56.540. Okay. So, bakit positive yung binigay kong angle? So, 56.540. So, 56.540, ito kasi, naka-polar form to. Ibig sabihin lang ang indication ng negative dyan is kung lagging or leading yung parameter mo. Since lagging voltage siya, kaya negative. Pero ang hinahanap lang naman is yung magnitude ng angle or yung magnitude ng firing delay angle. Kaya nakalagay dito is 56.450 degrees. Okay, so yung firing delay. Ano naman yung conduction angle daw? So yung conduction angle is pag pinag-add mo kasi yung firing delay tsaka yung conduction angle is 180 degrees. So therefore, para mahanap mo yung conduction, ima-minus mo lang yung nakuha mong firing delay dun sa 180 degrees. That will be 123.550 degrees. Ayan. So next na classic application ng SCR is yung tinatawag na SCR crowbar. Ano ba yung tinatawag na SCR crowbar or yung tinatawag na crowbar? So one of the most important applications of SCR is to protect delicate and expensive loads against overvoltage from a power supply. Crowbarring through a drastic form of protection is necessary with most digital ICs because they can take much overvoltage. The overvoltage that fires the SCR is VCC is equal to VZ plus BGT. Ito yung isang classic crowbar circuit. Pag sinabi kasing crowbar circuit, ang ginagawa nito is protektahan niya yung delicate loads or mga sensitive loads. Particularly yung mga ICs natin. Anong ginagawa ni SCR? Ang ginagawa ni SCR, pag nagkaroon ng overvoltage kay BCC dito, ang tendency is pag wala tong SCR na to, pag nag-overvoltage si BCC and yung rating ng IC mo is hindi niya kakayanin yung voltage niya pumasok sa kanya, ang mangyayari niyan is masisira yung load mo or yung IC mo. But pag may SCR ka at pag may overvoltage ka dito, ang tendency niya is ito-turn on niya si SCR muna. Pag na-turn on si SCR, ibig sabihin, mag-short circuit lang si SCR. Ibig sabihin, yung kuryente mo, hindi pa tutuloy din kay load. Tutuloy siya sa ground kasi shorted to. So, yun yung kahalagahan ng SCR crowbar circuit. So, para maprotektahan yung mga sensitive loads natin from overvoltage. Kasi pag wala yung SCR dito sa point na to, okay, once na nag-overvoltage yung BCC mo, sira agad to. For example, ang rated voltage na ng IC mo is 6 volts. Eh, nag-overvoltage to, naging 10 volts. Sira agad yung IC mo nun. Kasi tutuloy-tuloy yung voltage dito, yung current na malaki. But, kapag may SCR ka, okay, kahit pumalo to ng 10 volts, ang tendency lang yan is mag-short lang si SCR. Pag nag-short si SCR, ibig sabihin, sa ground tuloy yung kuryente, hindi papasok dito. So, naprotektahan mong hindi masira yung load mo. So, that's crowbarring. Okay, so let's take some examples here. Using the SCR crowbar circuit, determine the range of supply voltage that will turn on the crowbar if the linear breakdown voltage is 5.6 volts with tolerance of 5% and the SCR gate trigger voltage is 0.75 volts. That in worst case scenario can reach up to 1.5 volts. Okay. Ano daw yung range ng BCC mo na para ma-activate yung SCR? Okay, tingnan natin. So, ang formula natin is BCC is equal to BC plus BGT. So, pero, binigyan ka ng ranges ng Zenir tsaka nung sa gate trigger voltage ng SCR. Sabi, yung Zenir natin is may breakdown na 5.6. May tolerance siya na 5%. Ibig sabihin, plus minus 5%. So, therefore, 5.6 plus minus 5%, that will be 5.32 to 5.88. Okay? Then, yung ating namang SCR, meron siyang gate trigger voltage minimum na 0.75 volts na papalo hanggang 1.5 volts. So, ang minimum niya is 0.75 up to 1.5. Therefore, para mahanap yung range ng BCC na magta-turn on kay SCR or ito yung range kung saan mag-over voltage na at mata-turn on ng SCR natin, that will be, the minimum is, kunin mo yung parehong minimum nila. Minimum ng Zenir, plus minimum gate trigger. That will be 5.32 and 75. Pag pinag-add mo yan, 6.07. Then yung BCC max, kunin mo yung parehong maximum point. Yung maximum point is 5.88. Then, yung 1.5, that will be 7.38 volts. Therefore, ang range ng supply voltage mo is from 6.07 to 7.38 volts. So, ito yung range kung saan magta-turn on yung SCR natin or ma-activate yung SCR crowbar circuit natin. Okay? So, next tayo. So, SCR crowbar circuit has supply voltage of 10 volts. The Zenir diode breakdown voltage is 8 volts and the SCR gate trigger voltage is 1 volt. what is the minimum voltage of the load to avoid being damaged by overvoltage. For example, meron kang crowbar circuit, so 10 volts yung supply, then 8 volts yung zener mo, then 1 volt yung trigger ng SCR mo. Ano daw dapat yung magiging rated voltage ng load mo para kahit mag-over voltage is hindi siya maapektuhan. So, syempre, paano ba malalaman yun? So, kailangan pareho ng supply voltage mo yung rated voltage ng load mo para maiwasan mong masira siya sa overvoltage. Therefore, the load should have a voltage rating ng at least 10 volts. Okay? So, kahit mag 10 volts siya, since 10 volts yung rated voltage ng load mo, so kahit umabot niya ng 10 volts, hindi siya masisira kasi it can withstand yung 10 volts. Kasi yun yung rated voltage ng load mo. So, yun yung required. Kailangan equal siya sa supply voltage mo. Okay? So, that's the end of our discussion for SCR. So, may question ba kayo? Question? Question? Anyone? Uy, ano? Okay lang? Walang question? Wala. Walang question. Ano?